correct solution is to run a new neutral wire from the main panel to the third subpanel. The existing circuit uses the bare ground wire as a neutral, which is a safety hazard. The neutral and ground wires must be separated to ensure proper circuit operation and safety. The 220 volts breaker in the main panel should feed a neutral and a ground wire, not just a ground wire. To properly correct this issue, firstly turn off the power to the third subpanel. Secondly, remove the 220 volts breaker from the main panel. Thirdly, trace the existing 220 volt circuit from the main panel to the third subpanel. Fourthly, disconnect the existing bare ground wire from the neutral bus in the third subpanel. Fifthly, install a new ground bar in the third subpanel. Sixthly, run a new neutral wire from the neutral bus in the main panel to the neutral bus in the third subpanel. Seventhly, connect the ground wires to the ground bar in the third subpanel. Eighthly, replace the 220 volts breaker in the main panel. Finally, turn on the power to the third subpanel. There are also some additional considerations. If the existing 220 volt circuit wiring is in poor condition, it may be necessary to replace it as well. It is always recommended to consult with a qualified electrician for any electrical work to ensure safety and compliance with electrical codes. Understanding the importance of proper grounding and neutral connections in electrical systems is paramount for safety and code compliance. The scenario described highlights a common but dangerous mistake where a bare ground wire is used as a neutral conductor. This practice can lead to several hazardous conditions, including electric shock and equipment malfunction. Let's delve into the principles behind grounding and neutral connections, explain why they must be separate in subpanels, and outline the correct steps for rectifying such wiring errors. Grounding and neutral explained. The neutral wire serves as the return path for current in an alternating current, also known as AC circuit. It is typically connected to the grounded conductor at the service entrance, usually the main panel, where it is bonded to the grounding electrode system. This bond ensures that the neutral is at or near ground potential. Ground wires, on the other hand, are safety conductors. They provide a low impedance path for fault current to return to the source, which helps to trip a circuit breaker or fuse, quickly disconnecting the power and preventing electrical shock. Ground wires are connected to the metal enclosures of electrical equipment and appliances, providing a path for stray current in case of insulation failure. Why separate neutrals and grounds in subpanels? In a main panel, the neutral and ground are bonded together. However, in subpanels, this bond must be removed. The reason for this separation is to prevent neutral current from flowing through the ground wires. If the neutral and ground are bonded in multiple locations, it creates parallel paths for the neutral current. This can cause current to flow through the ground wires, which is undesirable for several reasons. Firstly, ground wires are not designed to carry continuous current. Secondly, current flowing through ground wires can create electromagnetic interference, known as EMI, which can disrupt sensitive electronic equipment. Thirdly, it can increase the risk of electric shock, as any contact with the ground wire could result in a shock if it is carrying current. A national electrical code, known as NEC, mandates the separation of neutral and ground in subpanels to prevent these issues. Specifically, NEC section 250.24 A5 addresses this requirement, stating that the neutral conductor shall be insulated from all grounded equipment, grounding electrodes, and grounding electrode conductors in subpanels. Correcting the wiring error. In the scenario described, the initial problem was that the bare ground wire was being used as the neutral conductor for the third subpanel. This is a clear violation of electrical safety standards. To correct this, the following steps should be taken. Firstly, disconnect the power. Before making any electrical modifications, always turn off the power to the circuit at the main panel. Use a voltage tester to confirm that the power is off before proceeding. Secondly, remove the improper connection. Disconnect the bare ground wire that is currently being used as the neutral from the neutral busbar in the third subpanel. This wire should only be connected to the ground bar. Thirdly, install a dedicated neutral wire. Run a new, properly insulated neutral wire from the neutral busbar in the main panel to the neutral busbar in the third subpanel. The neutral wire should be sized appropriately for the circuit load, as determined by NEC tables such as 310.15. D16. Fourthly, install a separate ground bar. If the third subpanel does not already have a dedicated ground bar, install one. This ground bar should be bonded to the metal enclosure of the subpanel and connected to the grounding electrode system. Fifthly, connect the ground wires. Connect all ground wires from the branch circuits in the third subpanel to the new ground bar. Ensure that all connections are secure and properly tightened. Sixthly, verify the connections. Double check all connections to ensure they are correct and secure. Use a multimeter to verify that there is no continuity between the neutral busbar and the ground bar in the third subpanel. Seventhly, restore power. Once all connections have been verified, restore power to the circuit by turning on the breaker in the main panel. Eighthly, test the circuit. Use a circuit tester to ensure that all outlets and devices connected to the circuit are working properly and that the grounding is effective. Additional considerations. Wire sizing and ampacity. When running new wires, it is crucial to select the correct wire size for the intended load. The ampacity, also known as current carrying capacity, of the wire must be sufficient to handle the maximum current that the circuit is expected to carry. NEC Table 310.15. B16 provides ampacity ratings for various wire sizes based on insulation type and installation conditions. For example, a 20 amp circuit typically requires 12 American wire gauge, also known as AWG copper wire, while a 15 amp circuit typically requires 14 AWG copper wire. Grounding electrode system. The grounding electrode system provides a connection to the earth, which helps to stabilize voltage and provide a path for fault current. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes connected to the main panel via a grounding electrode conductor. Subpanel grounding. In addition to the equipment grounding conductors that run with the branch circuits, subpanels must also be grounded. This is typically accomplished by connecting a grounding electrode conductor from the subpanel to the nearest available grounding electrode, or back to the main panel. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the ungrounded conductors supplying the subpanel. Bonding. Bonding refers to the practice of connecting all metal parts of an electrical system together to create a continuous electrical path. This includes metal conduits, metal enclosures, and metal equipment frames. Bonding helps to ensure that all metal parts are at the same potential, which reduces the risk of electric shock. NEC Section 250 provides detailed requirements for bonding electrical systems. RSI and GFCI protection. Arc fault circuit interrupters, also known as RSIs, and ground fault circuit interrupters, also known as GFCIs, are safety devices that provide additional protection against electrical hazards. RSIs detect arc faults, which are dangerous electrical arcs that can cause fires. GFCIs detect ground faults, which are leakage currents that can cause electric shock. The NEC requires RSI protection for most branch circuits in dwelling units, and GFCI protection for receptacles in wet locations such as bathrooms, kitchens, and outdoor areas. Conduit and cable management. Proper installation of conduit and cables is essential for safety and reliability. Conduit should be securely supported and properly sized to accommodate the wires they contain. Cables should be protected from physical damage and installed in accordance with NEC requirements. When running wires through walls or ceilings, use appropriate cable clamps and bushings to prevent damage to the wires. Electrical codes and standards. Electrical work must comply with all applicable codes and standards, including the NEC, state, and local building codes, and any other relevant regulations. These codes and standards are designed to ensure the safety of electrical installations and protect people and property from electrical hazards. It is important to stay up to date on the latest code requirements and to follow them carefully when performing electrical work. Hiring a qualified electrician. While some electrical work can be performed by homeowners, it is always recommended to hire a qualified electrician for any complex or potentially hazardous tasks. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in compliance with all applicable codes and standards. They can also identify and correct any existing electrical problems that may pose a safety risk. Safety precautions. Working with electricity can be dangerous, so it is important to take appropriate safety precautions. Always turn off the power before working on electrical circuits. Use insulated tools and wear appropriate personal protective equipment, also known as PPE, such as safety glasses and rubber gloves. Never work on electrical circuits in wet conditions. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Troubleshooting common problems. After completing an electrical installation, it is important to test the circuit to ensure that it is working properly. If you encounter any problems such as strip breakers, non-functioning outlets, or flickering lights, troubleshoot the circuit to identify the cause of the problem. Use a multimeter to check for voltage, current, and continuity. Inspect the wiring for loose connections, damaged insulation, or other defects. If you are unable to resolve the problem, consult with a qualified electrician. Continuous learning and professional development. The field of electrical work is constantly evolving, with new technologies and techniques emerging all the time. To stay current in the field, it is important to engage in continuous learning and professional development. Attend training courses, read industry publications, and participate in professional organizations to expand your knowledge and skills. Consider pursuing certifications and licenses to demonstrate your competence and professionalism. In conclusion, addressing the described wiring error by running a new neutral wire from the main panel to the third subpanel is crucial for ensuring electrical safety and code compliance. The separation of neutral and ground wires in subpanels is a fundamental principle of electrical wiring that must be followed to prevent hazardous conditions. By following the steps outlined above and consulting with a qualified electrician when necessary, you can ensure that your electrical systems are safe, reliable, and in compliance with all applicable codes and standards. Remember, electricity is a powerful force that must be treated with respect. Always prioritize safety and follow best practices when working with electrical systems. By understanding the principles behind grounding and neutral connections and following proper installation procedures, you can create a safe and reliable electrical environment for yourself and others. The proper wiring of subpanels is not just a matter of following code, it's a matter of ensuring the safety and well-being of everyone who uses the electrical system. By taking the time to understand the principles and procedures involved, you can make a significant contribution to electrical safety.